Welcome to the first webinar on the physical access. I'm Sara Pero, Communication Officer at EMSO ERIC. Today with me there is also Simo QC, which is our Engineer and Logistic Officer. And we will discuss about the EMSO Physical Access Call 2025 and also showcase some of the granted projects we granted through the last call. The Q&A session will be at the end of the webinar. So if you have any question, please write in the chat. And we will then focus on any kind of information on each project. So I will share my screen in a way that we can start the webinar. I would just give you an introduction on who we are for those who are not yet know us. EMSO ERIC is a research infrastructure. It's a distributed research infrastructure consisting of 8 countries members across Europe and 11 cable and standalone observatories with 3 test sites. We have 25 institutions involved, and we mainly focus on 4 pillars, which are marine ecosystem, climate change, geohazard, technological challenge, and 3 domains, which are hydrosphere, geosphere, and biosphere. Of course, all the marine sites are equipped with several sensor technologies to monitoring the ocean parameters, and which provided the data through our data portal, which is also available on our website. The EMSO ERIC mission is mainly to investigate, of course, the marine ecosystem, climate change, and geohazard, with a scope to achieve a sustainable management and protection of marine resources, aimed to understand the complex interaction among the geosphere, biosphere, and hydrosphere. We have, of course, as a research infrastructure, several challenges, which I summarize here, mainly concerning the global ocean warming and acidification, the impact sustainability of marine resources exploitation, the observation in real time or near real time, an early warning system for earthquake and tsunamis, which affect the marine environment, and also the monitoring of marine ecosystem trends and climate change mitigation, and of course the interaction among the hydrosphere and biosphere. This is just an overview about our research infrastructure. Of course, if you have any question, please ask during the webinar. I would just leave you with some contacts in case you need further information. And I would just also mention that we will organize another webinar on the physical access, aimed to promote our services, mainly also for the academic community. The webinar will held in March, 28th of March, same time, and the agenda and the registration for joining will be ready. Will be coming soon. I would now leave the floor to my colleague, Simo QC, to present our EMSO Physical Access Call for this year. So I will stop my sharing and give the floor to Simo, please.
Thank you, Sara. I don't know if you see my screen.
Yes.
You do, huh? I will put in presentation mode. Okay, so as Sara said, we are an ERIC, and as an ERIC, EMSO needs to offer services to the community. And this is one of the services that we have running now at EMSO. We started it in 2022. And we called it physical access because physical access means that the user that applies for this service goes physically to the facility or sends some instruments to the facility. So it's like a bit like a mechanical access to the site, as opposed to the virtual access, which is access to the data. No? So this is the difference, and this is why this terminology. Our program is very similar to other TNA calls from European funded projects. So TNA is Transnational Access Call. Many projects, or a few of them, offer the facilities for the users to access. But our program is a bit different because since we are a permanent infrastructure, we can offer this service continuously. And not just one or two calls during a project, but this is a service that is permanent and is at your disposal for using it. So every January we launch a new call that will last the whole year. And every January we might modify some things for the next year. No? So maybe we increase the budget, we reduce something, we improve something else. So every January there is some news. As I said, this is a service that we are offering, and it's aimed at external users, and they can be from the public and private sectors. No? This webinar is mostly now for private users. So as a private users, all SMEs and larger industries are welcome. The program offers access to the sites, to the EMSO sites, for testing technologies or realizing scientific experiments. So this can be helpful for you, for your companies, to access to develop new technologies, improve and test some prototypes and so on. The access duration of the project that you can do at our facilities can be short, but it can get up to, let's say, 2 years or so, because sometimes you need to test your prototypes in different conditions, different seasons, and sometimes the logistics is not so easy. So we give time to the people, to the user to execute the project. The user can bring their own equipment, and this equipment can be tested on the site. This equipment can be installed next to the facility equipment. So the facility equipment can be used as a reference measurements for your own experiment. You can also bring your equipment, and in some of the sites, you can install it directly to some node, and then you can have access, for example, from your institution, from your country, real-time access to your instrument that is measuring in the water. No? So there is all kinds of accesses that you can have. You can also have a remote access so that you can send your instrument, and the engineers and technicians at the facility, they will take care of it and they will install it at the facility. And for your project, you can use several sites. You can choose just to access one site, but for example, you can do a test on one side in the Mediterranean. Then the next phase can be in the Atlantic, for example, or you can test first at the shallow water, then move to a deeper site. So this is one of the advantages of our consortium, that we have a very varied set of facilities. So yeah, the regional facility members that are on the different sites, they will help you with the logistics, deployment and recovery, data access, interfacing equipment, and so on. And then from here, from the central management office, we provide a grant of 15,000 euros, up to 15,000 euros for the user to travel to the facility, to pay for consumables, batteries, things like that, for shipping material to the facility, for some operations if needed, divers and so on. And if something needs to be adapted for the experiment so that your technology can be adapted and included in the observatory. So moving to the facilities, this on the left, you see the map of the different facilities at EMSO. Not all of them are offering access right now, but this is just for you to see that the EMSO coverage. There are 14 sites and 3 of them are shallow. So the shallow sites are Smart Bay, Molen, and Opsea. And these sites are great for connectivity and easy logistics. So these sites are very close to shore. You can take a small boat and go there very easily. And they have great technical support from the teams on site. So this would be for testing technologies in a more easy way. And then we have the observatory sites that are a bit more offshore. And they require maybe sometimes some larger boats to get there. So the logistics is a bit more difficult, but then they offer a long time series of open ocean data for you to use, and more maybe open ocean conditions if your project requires so. So going to the current call of 2025, there are 6 facilities that are offering access. Smart Bay and Opsea as cable shallow test sites are offering access. Smart Bay in Galway in Ireland, and Opsea close to Barcelona in Spain. Then there is Iberian Margin, Western Mediterranean Sea, Southern Adriatic Sea, and Western Ionian Sea that are deep sites providing access. Iberian Margin south of Portugal, and the rest Italian facilities around Italy. So how to apply to the program? The application process is very easy. You just need to send us a letter of intent, which is 1 page that we have the templates on our website. And with this letter of intent, you just say that very quickly what you want to do and what facility you would like to access. Then with this information, we contact the facility managers and get back to you and with a solution for your request. And you can contact the facility manager and prepare a proposal. Proposal is also quite easy, not too long, 6 to 10 pages. And then when we have the cutoff date that we have every 2 months, for example, today is the last day of the first period. So we collect all the proposals and we send them for evaluation. So we are open the whole year, and it's every 2 months you can apply, and you will have an evaluation very soon. So you don't need to wait 1 year for us to be ready to evaluate the proposals. So the criteria for the evaluation is scientific criteria and the methodology. And also there is bonus points, a lot of them for industry applications. So we are very welcoming to industry, and this is reflected on this table. So the evaluation can take 1 or 2 months, and then 5 or 6 months after the deadline, you can start your project. So it's quite quick. And then 2 agreements need to be signed, one between the user and EMSO, and then one between the user and the facility for more like operational issues. So just to sum up, I will finish here. EMSO can be your partner for testing new developments at sea in real ocean conditions, and helping advance you with your technologies with the support of experienced engineers and scientists. The process is simple and the execution period is flexible. So it allows you to focus on the project developments without time constraints or continuous reporting. So far, we have 10 projects in these 2.5 years, 2 of them granted to SMEs, 1 to a large industry. And the 7 remaining ones, 2 of them have industry involved. So we are happy to have industry accessing our sites and testing new products that will quickly get into the market. Here I have some examples, but I think we are a bit short of time, so I will just move on. We will have the 3 projects presented here. So yeah, feel free to reach out to us on this email, and we can walk you through the process. As I said, it's very easy, and we are happy to help you on that.
Thank you, Simon. So now let's move on the granted project. And we will start with the Seagrass Blue, which is a project led by Craig Syms, Chief Scientific Officer of Seagrass Blue. This project is hosted in OPSI, our Spain site. So I will leave the floor to you.
Good morning. I'm Craig Syms, Chief Science Officer at Seagrass Blue. And at Seagrass Blue, we grow seagrass to remove carbon and increase biodiversity. So seagrass is a plant that grows in the ocean. It provides habitat for a wide range of species, including invertebrates and fishes. And seagrass can also improve water quality and stabilize shorelines. Seagrass is also one of the world's best natural carbon removers. 1 hectare of seagrass can remove up to 30 times more carbon than a hectare of rainforest. So if we planted seagrass in just 0.5% of all of the space occupied by ocean, we would be able to absorb all the carbon. But seagrass meadows are under threat from human impact, and restoring seagrass beds naturally is hard. Typically, the habitats that seagrass occupy have been so degraded by human activities that seagrass will not recolonize into those areas, even with the best planting and rehabilitation efforts. So our innovation is to grow seagrass in midwater farm pods in an aquaculture solution. Seagrass needs sand or mud to grow on, and the water and light conditions need to be right. So what we do is we build modular pods that are filled with sand and planted with seagrass cuttings. We place pods in mid-water, probably about 10 meters below the surface, to optimize growing conditions. And as we aggregate the number of pods up in size, we gradually build a farm in an effort to scale up carbon capture and biodiversity increase. We monitor seagrass growth by a swarm of marine bee robots with additional diver collected data to provide extra verification. In combination, these provide verification of the amount of carbon captured. And as the seagrass beds develop and increase and vegetatively increase, this increases the local biodiversity of invertebrates, fishes, and acts as a nursery full of juvenile fishes as well, so contributing to fisheries. But a solution like this has considerable challenges. Seagrass aquaculture of any kind, let alone on platforms in midwater, has never been tried before. If it is to be successful, there needs to be a real-world proof of concept to provide a platform for which we can scale up to economically and globally important scales. And as with any enterprise, we need monitoring to measure the effectiveness of the approach. And this is part of a transparent verification process. As a business, if we are selling carbon or biodiversity increase, people need to know that it's actually working. So this is critical to what we're doing. This brings me to the EMSO Physical Access Program. So for our prototype pod, we needed a location that was relatively close to shore for access, not too deep for our moorings. Our marine bee robotics also needed 4G connectivity for communications. They're critical to our verification process. So the OBSI Seafloor Observatory, located 4 kilometers off the Villanova Ilha Geltrú coast, is in an area that's protected from fishing and fishing disturbance, and this location was ideal for us. The observatory is managed by Polytechnic University of Catalonia staff, who, in addition to understanding the process of deploying and maintaining instrumentation, particularly on the seafloor, they also have expertise in seagrass cultivation and rehabilitation as in a supplementary program. So in combination with their partnerships with local marine engineering companies, this made it an ideal place for us to test our prototype. This project is ongoing, but broadly there were 3 phases. We constructed a prototype pod, which was then deployed by a commercial marine engineering company. These structures are heavy and require a significant amount of infrastructure to deploy effectively and safely. The next phase was carried out underwater, and that consists of us going into the water and further stabilizing the pod and planting using fragments that the UPC labs provide as part of their seagrass rehabilitation program. I'll have to say we are currently at the stage now because of delays with the engineering. But concurrent with this, we're doing our robotics testing of the marine bees and just really getting all of the systems operating together and integrated. There were several challenges that we faced, primarily engineering delays with weather conditions and the company that was putting the pod in the water. And this really is just a consequence of working in the real world. And fortunately, the program is flexible enough for us to be able to work around these solutions and just deal with them as they occurred. But getting the prototype in the water is really key to part of the success of the project, in that we can see how this physical structure interacts with the ocean, how we can eventually scale it up, see what the problems are, see what the challenges are. There was also a need to be agile and flexible with our robotic monitoring, because we found that the ocean conditions, particularly some of the tidal currents, were stronger than we anticipated. So this led us to generate further advances and solutions to these problems, which ultimately makes for a better product. But overall, we see this as a good platform to build our larger solution. Getting the opportunity to actually integrate all of our systems together from beginning to end, to getting our data solution together, is certainly been very, very productive. In the immediate future, we'll further develop our technology solutions and continue to monitor and model the seagrass growth and see how biodiversity is changing and increasing as the pods become more and more vegetated. This is key to us developing our verification process. We've developed some important synergies with UPC during the course of this work. First, they have an interest in deploying instrumentation on our pods to test some of their components, particularly with measuring chemistry, water chemistry around the pods. Second, we can compare notes and ideas on potential seagrass restoration work. We effectively have a platform that they can monitor. They can see how seagrass is growing with planting out, test ideas, and we can go back and forth and just work out the best way that we can work on restoration efforts. But ultimately, our work within the EMSO Physical Access Program has enabled us to achieve our key milestone as a step to developing a scalable approach to removing carbon and augmenting marine biodiversity. And as I understand it, we will have questions at the end of the session. Thank you for your time.
Thank you, Greg. So let's move on the second project, which is Seasnake, led by Katarina Bokström from Research Institute of Sweden.
Thank you, Sarah. So my name is Katarina Bokström. I work at RISE as a project manager. And I would thank you for giving me the opportunity to tell you about our offshore cable solutions. So you can take the next pictures.
Yeah.
Next picture. But of course, we also have a challenge, and one of any positive challenge is that the offshore wind energy market is growing, and it's predicted to grow even more. And the European Union is a big part of this. And of course, this growth is because of technological advancements that make innovations that make the wind energy more effective and less cost. We also, of course, have some supportive policies from the governments, since we all want to enhance the renewable energy naturally. And also, as we know, the global energy demands are increasing. So that's one of the big challenges. So you can take next picture. And for us, and we work with medium voltage cables in this project, and that is critical for transmission of power from the wind turbines to the grid. And the key challenges for this is durability and resistance, since it's a harsh environment down in the ocean. And then we have the biofouling, which, as you know, like barnacles and algae that will grow on the cables. And this biofouling will or could reduce performance of the cables. It could increase maintenance costs, since we need to somehow get rid of it, and shorten the operational lifespans, which also will make it more or less cost effective. So next picture. So we have, when we applied to EMSO ERIC, the project Seasnake was about to start or ongoing. And today we have a project called Seasnake Plus, which is very good. So we know that all the data from EMSO ERIC is taken care of. So we applied to EMSO ERIC 2022 call, and the things that we have down in the ocean is still there. So Seasnake involves a large industrial consortium covering the whole value chain for marine and dynamic cable sector. So RISE, where I work, is the research institute, and we are also coordinating both Seasnake and now Seasnake Plus. We have ITEC, which is a company also based in Sweden, which develops, markets, and sells the performance ingredient Selektope for use in marine anti-fouling coatings. We have NKT, that is mostly well known for offshore high voltage cables, but they're also producing medium voltage cables that we are using in these projects. We have Geico, which is an Italian multinational company that work with systems for body painting of cars, but of course they can systemize painting of other things as cables. And we have Green Sailor that develops new coatings and new paintings, easy to use and without technical restrictions. Yeah, you can take the next picture. So our main objective is to analyze the impact of the biofouling. So we need to validate the material's durability, corrosion, and the biofouling. So that's why we need the long-term exposure at sea under different oceanographic stressors and conditions. We need to prove the effectiveness of anti-fouling painting, and we need to support the development of coherent protocols for testing innovative materials and cables. Yep, then you can take the next picture and I will. So we choose the Western Mediterranean Sea Regional Facility since they're able to carry out the experiment that we wanted to do. They're capable of deploying heavy and long pieces, which we needed, and also in a vertical position down to 30 meters, which was our suggestion. And on the picture here, you see this platform. So in the left, the yellow left part, you see what's above the surface. And then by the 6 arrows is where we have our cables. So it's 6 triplets of pieces. If you look at maybe it's easiest, the first arrow, it's possible to see that there are triplets of pieces. So there are 3 pieces. And one of them is not painted with anything. So it's just the cable. And the other 2 are painted with 2 different types of paint. Yep, you can take the next picture. So here, everything was deployed at sea in May 2023. So you see where they're painting the cables and expecting them, and also heat shrinking the end caps. There was a first visit with divers last summer in July. And we're right now planning a second visit during the spring as soon as the weather is good enough and the meteo marine conditions is good. And we're also then ready to recover the cables for inspection, analysis, and weight at the second visit, or a little bit later than that. So next picture, please. So here you can see some of the pictures after 13 months. And on your left, you see a sketch of this platform. Like if you look at the number 6 on the sketch, that's where the lowest cable is. And you see the picture of those cables with a lot of biofouling. Maybe it's easiest on picture 2, where you really see that there are 3 different cables or cable parts that is down the ocean. So here we can follow it, all the cables. And also during the deployment, of course, environmental conditions are recording, such as temperature, salinity, dissolved oxygen, turbidity, and chlorophyll. So when we have the second visit during the spring, there will be more pictures and more videos. Yes, you can take the next picture. I'm trying to sort of speed it up a bit. So we did have a first result, a presentation during European Maritime Days in May 23 when we presented the project. And we're also planning a scientific publication to discuss technology and the approach and to disseminate the results, of course. And then we have the ongoing project Seasnake Plus. And you can take that last picture. So here we have a picture of all the logos of all this consortium, which you can see is quite big. We are keeping on the work with looking at the biofouling and coating protection. So we're doing even a new kind of paint. We're also doing a robot for cleaning the cables. And in this part, it's very interesting for us to know this cable that is in EMSO ERIC with no paints at all. How much biofouling will there be after almost 2 years? How much will that weight? How much will it affect the cable? That's super interesting. And in this new project, we will also use fiber optics to understand more how the cable moves and model and predict movements according to weather. So hopefully we will be able to calculate cost reduction and hopefully contribute to more sustainable energy with this better cables that will be less cost effective, more cost effective to use. So if you want more, please look at the website seasnake.eu or find us on LinkedIn. Thank you.
So thank you, Katarina. Now let's move to the last presentation. This is the project started some few months ago in the Spanish side of OPC, led by Marc Lucas, senior oceanographer and project manager from CLS. So please, I leave the floor to you,
Yeah.
Marc.
Can you hear me? Yeah. Good.
Yeah.
Okay.
Good.
I'll just share my screen. Yeah. Can you see my screen properly?
Yes.
Okay. Excellent. Okay. Hello, everybody. Thank you very much for giving me this opportunity to present what we've been working on in partnership with EMSO ERIC. So I'm Marc Lucas. I work for a company called CLS, which is based in France, which focuses on delivering services linked to the processing of satellite data. And one of the things we've been historically doing actually at CLS since the 1980s is providing the telemetry, so the communication for drifting buoys at sea. This was one of the first things we started doing almost 40 years ago. So probably quite a few don't know, but there's over 1,300 drifters at sea continuously. The idea is to provide meteorological data for weather forecasting, so namely surface sea level pressure and also sea surface temperature. Every year, there's about 600 of them which are deployed, and they're quite big and heavy in terms of plastic. They weigh around 25 kilograms, and their dimension is basically a sphere of 40 centimeters in diameter. These buoys are not recovered after use because it's considered too expensive, and so we have a bit of a pollution problem. It's a significant issue actually, because they're just contributing to the issue of marine plastic. And there's a kind of a easy way out justification used by scientists, which is basically the value of the data outweighs the impact of the plastic. But some people think this is not really acceptable. And so in conjunction with ESURFMAR, which is the European body which deploys these buoys, we've been working on an alternative to the plastic solution, and we're basically developing a wooden buoy. So basically, the idea of this project is to develop a new type of platform with a hull made out of wood. We want it to be reusable, so you can open it and easily change the batteries, for instance, competitively priced, and also robust because, as you know, the ocean is quite a hostile environment. And in this project, we're hoping to reach a technical readiness level of about 6. So we're based in Toulouse. So we don't have a test site, as you can imagine. So which is why we kind of looked for EMSO for solutions. We needed basically to perform sea trials in an unprotected site. So basically in areas where the wind and the wave would affect the instrument. Also, we wanted to have reference sensors available for comparison, notably for the sea surface temperature, and a support team on hand to help. So if something goes wrong, they can go and pick it up, and do that kind of stuff. And we were also very interested in the one-stop approach. So basically, the capability that EMSO has of providing everything, helping us to kind of hire the boats and to go out. That made things much easier for us. So we end up working with EMSO OPSI, so in Villanova, mostly because of geographical proximity. It's not too far from Toulouse. We've also done some previous collaborations with UPC, so they gave us a bit of information on EMSO. We hadn't heard of it beforehand. For us, it was also ideal testing conditions because of the way it's kind of, the site is away from the shore and exposed to the elements. And there's also quite a significant suite of sensors. The type of data we were looking to collect in our project is GPS location, so this is sent by the buoy. We also wanted to have an information on the battery status. We provide also feedback on the satellite telemetry, so how long it took for the buoy to transmit the data to the satellite, how much of the data was transmitted, what was lost, and that kind of stuff. We also wanted to get information on sea surface temperature, so this from the buoy and also from the OPSI instruments. And also we were interested in getting wind and wave data from OPSI so that we can kind of see the meteorological conditions to which the buoy was submitted during its time out at sea. So the project is ongoing. Our next step now is, so we've kind of validated, if you like, the general design of the buoy. We've also validated if you like, the temperature sensor we've been using and the water tightness of it all. We're now working on adding a barometer. So for this, we need a slightly larger hull. We want to revisit the sealing process to make things a bit more robust. We're looking to improve the electronics also to kind of, so one of the issues we have is obviously once the buoy is closed, we need to be able to communicate with it. So when we do the setup, so we're working to add a kind of a buzzer so that people know what's happening and then can communicate with the electronics via Bluetooth. And then a big step for us is to test the Argos Kinase constellation. So this is a European or French European, if you like, IoT type of constellation, which enables basically the buoy to transmit the data back to land. If you like, the buoy deployment program I mentioned at the beginning for meteorological purposes is predominantly the telemetry is predominantly performed by Iridium, and a lot of the buoys are actually American and are actually deployed by NOAA. And currently, there's a lot of uncertainty on what's going to happen to the staff, what's going to happen to the funding. So for us, it's important that we have a European solution for the data transmissions. That if something happens to Iridium or we're not allowed to access the data anymore, we can still receive this type of data, which is vital for the weather forecasting. So thank you very much. And if you have any questions, I'm happy to answer them in due course. Thank you.
Thank you, Marc. Let's move now to the Q&A session. Of course, if you have any request of information, please write in the chat to me. We have a first question by the audience for the Seasnake project related to the ongoing results, let's say. So the question concerning to the painting. So if there is a difference between the cables treated with the painting and the other not cover with the specific.
That's what we're waiting for to see. And I think to really see that, it's not enough just to the photos and the videos. So when we take the cables up from the ocean, we can do the real analysis and see how it differs between the three pieces and in the 6 depths. So we will see when we analyze the results.
Okay.
Especially the ones that, as we could see in the picture from last summer, the ones that are at 30 meters, there's so much biofouling, so it's hard to just in the picture see if it's less or more on the different pieces.
Yeah. Also, the biofouling should be a critical issue also for the long-term maintenance of the monitoring aspect related to the ocean observation. So I imagine that this project is particularly interesting for achieving some results or on this aspect. So thank you, Katarina. Let's move to the second question. It's referred to all the 3 speakers, and it's concerning the sensitive of the intellectual property. So how do you feel regarding your project respect to the intellectual property? I don't know if we can start with Craig, since it's the first project showcased.
Yes, thank you for that. I don't think we've seen any, there's no conflict that's been apparent at all. It's been very cooperative, and we're keeping the technology very separate, but then again, we're relying on our own communications and our own robotics and we're using a 4G network rather than the cables that is provided by the observatory. We just see it as a synergistic relationship. So the nature of the project is that we're not really particularly concerned about any sort of intellectual property conflicts or anything like that. So I think it's just worked very well for us. We have a technical officer is in the meeting. That's Chris Lewis. He may have some other comments.
And for our project, I wouldn't see that would be a problem for now. I mean, there is no recipe on the painting that we're using that anybody will see for now. And also exactly what the cable is manufactured by is not something that is public either. So at least we don't see a problem with that now. I see that Roberto Bosano is having his hand up. Maybe he wanted to, since he was part of my project, maybe he wanted to say something.
Yeah, just let's say a minor note related to the type of painting, just to integrate what you have just said. So in this deployment, one type of painting was a so-called fouling released painting. This means that it is not supposed for the painting to avoid any, let's say, growing of algae or barnacles, but it is supposed that it should be easier with respect to other paintings to clean the surface, or in this case, the cables. This is a minor technical note.
Yes, thank you.
Thanks, Roberto. I don't know if Marc would like to comment something about the last question we received from the audience.
Yeah, no. So for us, actually, the more people who copy us, the better. We're trying to kind of get the people, wean the marine, scientific, and technological, if you like, bodies away from plastic. So if anybody, feels that, wood is the answer to any of their problems or is worth testing, for us, it's good. I mean, we need kind of us alone wouldn't be able to solve the marine plastic issue by ourselves. So yeah, the more people kind of are inspired, the better, I would say.
Okay. What about the future on your project related to the potential publication or potential collaboration with EMSO ERIC sites in which your project is already hosted? Let's say, it's on my curiosity about if you plan to have some joint publication, or it's too early to discuss or have some information on this. And also, how did you find your experience in accessing the regional facilities of EMSO ERIC?
Well, I can start if you like. I think because we're at a very early stage of the enterprise, having collaborations and continuing collaborations, particularly with the academic side of things, with the UPC, is something that we'd certainly look towards trying to establish, because we sort of have the business side. I mean, my background is academic. The founder of Seagrass Blue is Internet of Things technical side. So having a collaboration with an academic institution would be very useful for us and very productive for both ways. So I think anything that we could use to leverage this project as for further collaboration with the EMSO sort of program would be great for us. The prototype serves as a demo for us from the business point of view, but I think we sort of need to keep these things going because nobody's really tried this before, and it's a learning sort of experience. So the more we can draw on lessons from people working on seagrass restoration, like some of the UPC folks, with the facility, and then building out sort of our tech and our hands-on way of doing things, I think it'll be a productive thing. So certainly something that we'd look forward to trying to continue and extend.
Thanks. I don't know if Katarina or Marc would like to add something.
Well, I just know that the results we will of course publish and we will not just publish for this, but also using it in the ongoing project, since it's very important to see to compare when we're going to do the calculation of the cost effectiveness of the new thing that we're developing. I don't rule out, of course, a new application to EMSO, Eric, but it's not anything that we're not discussing it in the ongoing project now, but I would say that there's a big chance of doing it again.
Yeah, and on our side, I think, well, first of all, I think it was I think Simo kind of highlighted how easy it is to put in a proposal, and that's really important because we're private companies. Well, no, I guess everybody, even researchers, also have don't have that much time. So it's nice to follow kind of a simple process where people kind of help you is a relief in today's world, because lots of time, project proposals are very long and very cumbersome. So that was very, very nice. And yeah, for us, we've got the second version now with the barometer, which we probably want to test somewhere. So we'll have to think about that. And obviously, we're going to kind of we're not too sure about a formal publication because that takes a lot of time. But we're going to start, obviously, sharing our results and with as widely as possible to kind of reassure people that wood is an effective alternative to plastic. And so yeah, for us, to have like I was saying, the data from the site in terms of like the wind, the waves, and the various conditions is important, I think, for people to kind of think, okay, it's worth, it's not too much of a risk to use wood for gathering in situ data from the ocean.
Thanks a lot, Marc. I don't know if there are any other questions from the audience. No. Okay, I don't know if the speaker has something more to add. Okay, so we are in time with our schedule time for concluding our webinar. So I would like to thank all of you for your contribution and participation.
I'd like to thank you, Sarah, and thank all the attendees and the speakers for the presentation. I think for EMSO, it's really important, this type of exercise in terms of webinar, but also the experience that has been led in collaborations with you all. So we are very grateful for that. And on behalf of EMSO, I thank you a lot.
Thank you. Goodbye.
Thank you.
Bye. Thank you.
Thank you. Goodbye.
Bye-bye. Thank you.